call it logical underscore relational. I'll call it that way. Then I'll just hit add. So you see, I have logical relational. Yeah. So I'll create my main. So I'll say, let's use the sub sub main. So we have, I just hit enter. When you do this, just hit enter, and to bring you the end main. But as it is sub, then the routine name, and then end sub. That is all. Good. So I have here logical relational. I need to rename all of them. So by the time you get the file, everything will be renamed so that you know which module contains what. Yeah. All right. So today we are looking at the first thing we are looking at is logical operators. Or actually, I think I should have made one just relational and one logical, but no problem. Let's start with relational operators. So these relational operators, like I said, we use them to compare two or more items, especially numbers. So before we do that, there is something we'll be doing after this particular two topics, which is the if and if-else statement. We have if statement, the if-else statement, then we have the if-else-if statement. The if statement, the if-else, then if-else-if statement. We shall be looking at it after this particular one. But for the purposes of this lesson, I'll be introducing the if-else statement briefly. Not the if-else. I'll be introducing the if statement briefly. Just the if statement briefly. You shall be seeing it here, but I'll touch on it more in the next lesson. But once you see it here, it will become clear to you how it is written. Good. So there are six relational operators. So let me do this. Let me comment here and say relational operations. So there are basically 6 relational operators. The first one we have is the first relational operator we have. We call it the equality operator. Equality operator, and it is represented when you come to vb.net. It is represented with the equal to sign. When you go to some other programming languages, it is represented with double equal to sign or triple equal to sign. Equality operator. The equality operator. This is not looking at, this is not trying to say it is equal to. No. It's not trying to say it is equal to. There is a difference between the equal, yes, we call it the equality operator, but it doesn't check whether it is equal to, but it's rather comparing them. You can say that, yes, oh, it is checking if this one is equal to that one. That's how you see it when it is written. It is checking if this one is equal to, but it is rather checking if the one side is the same as the other side. It's different from saying 2 plus 2 equals 4. You see, logically, if you look at 2 plus 2, if you add 2 items to 2 items, it gives you 4. Then at the other side of the equation, there is a figure which is 4. So if you see something like 2 plus 2 equals 5, logically, when you see something like that, and nobody can convince you that it is true, that 2 plus 2 is equal to 5. Nobody on this earth can convince you that it is true for you to also believe that, yeah, 2 plus 2 is equal to 5. So the equality operator is not trying to tell you that something is equal to the other. No. It is trying to tell you that it is comparing the two to see if one side is the same as the other side. If one side is the same as the other side, that is what the equality operator does. Like I was saying, when you go to other languages, like say JavaScript, by now I quite believe that everybody has at least gone to look for, like not gone through other languages, but gone to probably read a little bit about other languages that exist. Yeah, when you pick a language like JavaScript, Java itself, there's a difference between JavaScript and Java. Yeah. So when you hear me use JavaScript and Java, they are two different languages. Good. So when you pick like PHP, Java, JavaScript, probably Python, you are going to use either the second one or the third one. The second one is loose, but the third one is strong. Like for the third one, it means that you mean what you like. You should strictly check. You should strictly check if that one side is like the other side. Great. Let's now move on to the second type. So like I said, this when you come to VB, it is strictly this. It is strictly this one. But when you go to other languages, you are going to use any of these two in other languages. So if you see this one in another language, don't be surprised. It's still the equality operator. Let's now go to what we call the inequality. Inequality operator. The inequality operator. Good. The inequality operator, when you come to VB.NET, is represented by this, either this, or you can have that, unequal. So this is like saying not equal to. It's not equal to. This one normally we use it to compare strings or numbers, anything at all, dates, every data type. You can use these relational operators to actually compare. So we have the equality operator, the inequality operator. When you come to VB.NET, it's like two greater than and less than facing each other. It's greater than and less than, or less than and greater than facing each other. In other languages, this one is used more in other languages. So if you go to other languages and you see this, don't be surprised. It's still the same inequality operator. So we have the inequality operator. That is the inequality operator. Then we have, number 3, which is the greater than. By now, you should know how comment works. By now, you have the greater than. And as for this one, we all from class 1, we have all seen greater than till today, right from class 1. Let's say basic 1. Yeah, we have seen it up till today. So that is the greater than. So there is not much to be spoken about here. Compare two sides. This one, you can't compare whether A. Okay, you can still compare alphabets. Yeah, in most cases you can compare alphabets to determine whether A is greater than B, B is greater than C, C is greater than that kind of thing. But it's more preferable when you are using to compare numbers. So the fourth one is what we call as greater than has followed. You probably know that less than will follow. So this is the less than relational operator. This is the less than relational operator. Then the next one is greater than or equal to. Greater than or equal to, which is greater than or equal to. Greater than or equals. and it is written as greater than. This is how you use it actually. Greater than, so it compares probably two numbers. When you are comparing maybe 5, 5, 6. So, or 6, 6 and 5. So 6 is greater than or equal to 5. 6 is greater than or equal to 5. And it is true. 6 is greater than or equal to 5. Yeah, so you can compare stuff like that. It's a number greater than or equal to a certain number. Good. Then the last one, which is 6, the sixth one is less than or equals. Less than or equals, which is this. Less than or equals. So we have, these are the 6. Basically, these are the relational operators we shall be using throughout your entire programming life. Let's start with the equality operator. So let's create an example with the equality operator. Copy this and come and paste it somewhere here. So the equality operator. Let's get some variables. So you say that dim a b as integers. So, integer. There is, so we have dim a b as integer. At this point, I quite believe everybody is okay, comfortable with the a b that I've done. I've declared two variables. One is a and one is b. I've declared, but since they are both integers, I can combine them and make them one. Like this. Dim a comma b. So I'm separating them with a comma. So let's continue. So let's look at relational. I've told you that this is used more in VB. This one is for the other language. Let's move on. So dim a b as integer. Then, like I said, I want to introduce something small. The if statement. The if statement is actually used to take a branch. Let's put it that way. We normally call it the decision making block in programming. It helps you make decisions in programming. So if something is that, do this. If it's not, don't do this. Something of the sort. So it's just like conditional. Say they are conditional statements. We will go into conditional statements deeper. But for today, I want us to, for the purposes of our lesson, I want us to pull some aspect of conditional statement and then use it to support what we are doing today. So I'm saying if you want to write a conditional statement in VB.NET, which is the if statement, this is how you go about it. You say if something, so if something, then something, and then you do end if. Forget about the red lines. I will make all of them go away. So if something, then something. You see, VB is so beautiful that it doesn't stress you out with using the bracket and all that. If you go to other languages, it will prefer that you bring brackets before you write whatever statement you want to write. It will prefer that you bring the bracket. It's not that it will prefer. It is the convention there that you bring the bracket. So you write your logics inside the bracket. So under normal circumstances, that's how you should write it. So you say that dim a b. Then let's say a equals 5, b equals 6, like that. Then we say a equals b. You see, VB is not saying don't bring the bracket. It doesn't really care whether the bracket is there or not. But if you remove the bracket, it has no problem either. That's what I'm trying to say. So if you remove the bracket, it has. But if you go to programs like JavaScript, PHP, I have asked everybody. Okay. All right. So if you go to programs like JavaScript, PHP, for those ones, it's a strict that you have to bring the bracket. You have to put your statement inside your bracket. If you go to Python, there's a way you write the if statement, but Python also doesn't demand any bracket. Let me write something here for you guys. We are not doing JavaScript. That's why I don't want to fuse in too much from other languages. It can at times make it confusing. If you are doing this in JavaScript, you are going to write it this way. This is how you write this in JavaScript. Oh, sorry. Then it shouldn't be there. VB is forcing me to do what I don't want to do. So let me just pass comments throughout here. Good. Then let me show you how you go about it in JavaScript. So this is how you write an if statement in JavaScript. Like this. Straight. So you write your statement here, maybe A equals B. Then your code will be here. Whatever you want to see. Everything you want to see will be in here. So code here. This is how it is done in JavaScript. This is how it is done in C#. This is how it is done in Java. But like I said, you and I, right now, we are learning the logic. The logic is that this is a conditional statement. This is a conditional statement. Once you are able to grasp this, that if A is, and you meet it this way, you just have to learn in JavaScript how it is written. It is very good you are bringing the logic from other areas into this place. That tells you that you have seen this logic, or you have seen this concept. Let me not use logic. You have seen this concept somewhere. So now let this one solidify it for you. Let's look at it. Let's look at it. If we go to Excel, I know most of you have done Excel, a little bit of Excel. It will say if, then you bring the logic here, and then if true. So let me say if true, like this, if true, then comma, if false. This way. This is how Excel writes an if statement. This is how Excel writes it. Let's now compare this thing to the top here. Our if is there. Where is the logic? Where is the logic when you come to Excel? Where is the logic? This is the logic. Where is the if true and if false? That is what you write in here, in between here. But we haven't done that yet. So let me let these two remain. Then when we do it, you will get when you compare it to Excel, you get the true picture of how Excel does it and how VB does it. So you see that Excel and VB, they are doing the same thing. The same concept is being applied everywhere, even in Excel, which is not a pure programming language. Even in Excel. So like I always tell you, your console.write and your console.read must always come to support you. This time around, you are seeing that we are putting it inside the if statement. We are putting it inside the if statement. So today, we are not supposed to do conditions now, but like I said, I want to bring it, and I'm very much confident that everybody looking at the if statement this morning at least has seen it somewhere in other areas, like especially in Excel. Has seen it somewhere in Excel, and is trying to apply the logic here. It's the same thing here. Just that this one we are using codes to do it. But it's the same concept across. Good. So now we say that if A equals B, if A is equal to B, right, probably let it display true. Let it display true. So if we don't see anything, we won't see true. Sorry, if we don't see anything, then it means it is false. It is false. So it seems like today's lesson is becoming interesting to me myself. But let's and the time I don't think we can cover everything that I've put here. But let's move on. So A equals B, then we must see true. We have A is 5 and B is 6. So let's run this. I don't know if today, dear, if this thing is able to show without me switching to another screen like I'll be very happy. I'm not sure. Oh, sorry. Please, it seems we didn't do one thing. We didn't switch. So please don't forget. Always don't forget. Whilst we are doing the console, like I said, I don't want us to be deleting the modules that we create inside this our big project, our small project or big project. It's not a small, it's a big project. But what we are doing, we are writing programs. So this is a complete software. What we have done is a complete software. Yeah, you can do this and show it to somebody. Actually, the person will clap for you. Always switch to the current project that we are doing. This one there, I'm not walking anybody through again. Yesterday I walked all of you. So always switch to the logic. So today I'm using this module, the logical and relational. When you create a new module, it will automatically appear here. So then for this one, as soon as you make the changes, please save the work. If you don't save it, yeah, for the other ones, if you use a module and you save the work, and you don't save the work and you run, it will automatically save. But when you come to your settings side here, your properties, and you don't save after making changes, the changes will not take effect. All right, so let me close this for now. Let's continue. So let's run this. Read line. Okay, so nothing displayed. It didn't even run. The thing just appeared and disappeared. Yeah, it appeared and disappeared. I don't know if you are doing it at your end. You should see that if you wrote the exact thing that I wrote, it will appear and disappear. Why? It has nothing to display. A is not equal to B. A is not the same as B. A doesn't share equality with B. But if we put something like 5 here and we run, let us run. I want to see if you see it at your end. If you don't see it, that means I have to go full screen. Please, do you see the true statement in my CMD box? It doesn't appear. I don't think it appears. Sahara 2 and Yali, your hands are still up. Yeah. Okay, it seems like it doesn't appear. I have to stop sharing and share the full screen. Full screen, I don't enjoy using the full screen. Yeah, so let me run it again. So with this one, the first one, now check the first one. When I wrote 6 here, check, and then you see that it will just flash and go because it is false. Yes, it's false. The statement is false. So it will not, A doesn't share equality with B. This is not to say A is equal to B. No. This is to say is A the same as B. But the A is not the same as B. So A doesn't share equality with B. Now if I make it 5, so it will be A is 5, B is 5. If I make it 5, let's see. 5. I should have restarted my machine before starting this class. It has been on for the past 48 hours. I haven't moved actually for the past 48 hours. So true. So it's not, the true is not like we are telling it to use a boolean or something. We are just telling it true, like we should display true here. Simple. That's all that we are telling it to do. That should display true here. All right. So this is about relational and equality. This is about equality operator. So if you compare the same thing here, we are telling it that if you come to VB, it would have been something like this. If then we say A equals B, or let's use the small one now. If A equals B, if A equal to B, that is in VB. That's how we would have written it. Sorry, in Excel, that's how we would have written it. If A equals to B, then you should write here true. True. Else, you should do this. You shouldn't write anything. This is how it will be done in Excel. So if A equals B, true. So it will display the true. If there is nothing, so if it's not the same, it will actually display a false, like nothing. Because in our case, we are saying nothing. Let's now move from here. Let's now move from here, and then let's come to this point. So I think it will be appropriate to okay, for the A and B, we shall be using it throughout. So I think we can maintain this at the top, very top of our code, up here. Yeah. Let's say after this, we can maintain it here, because everywhere we go, we will be using it. But we have to be coming back and changing and all that. Let's comment them out. Then let's build a new one. So let's comment out this one. There's actually a shortcut for the commenting, but this one, the shortcut Control K, Control C. I don't like using it. Yeah, if you go to other languages, like as when you are doing like markup language like HTML or say CSS, Control and / and to comment. Let's go to the second one, which is the inequality. I can bet you that at this point, if I leave the rest to you, you can easily understand, play around it and understand. But as a teacher, I don't think it is best. Even though I'm teaching adults, I still feel like going through with you. So this is 2. So 2, let's still use the AB as integer. Then let's do something here. So A is equal to 5, B is equal to 6. Great, as usual. This time round, we are using. You see, this one is assignment. I think I mentioned this. This one, you are assigning a value to A. Please don't get confused here. Here at the top here, you are assigning a value to A. It's R2 back, it's not. At the top here, you are assigning a value to A or B. This one is value assignment. But with this one, you are doing a comparison. Please don't confuse the two. Here, you are assigning a value to a variable. You are assigning a value to the variable. But at this point, you are doing a comparison. You are comparing two values. You are comparing two values. Great. So we say that if A equals B, then we are now doing inequality. We say that if A is not equal to, so this one we say that not equal to, so inequality, not equal to. If A is not equal to B, then you should write it. So let's run this and see. And if you look at it logically, you know that A is not equal to B. So definitely it's going to display something for us. It's definitely going to display something for us. Let us change the true and let's do hooray, something like that. Let's just do this. So A is not equal to B. So this one we say if A is not equal to B, then write hooray. So we ran and we saw that something actually happened. That means that if we do this, we are not going to see anything. We are not going to see anything. Good. Nobody is asking why I'm not adding else, the else statement. Yeah, I don't want to make it too confusing. So in our case, we should just put it in our mind that for now, we should just put it in our mind that if it doesn't run, if the console interface, if the CMD interface, or the terminal, if the terminal doesn't show anything, or if the terminal doesn't run, if the CMD terminal doesn't run, then our code didn't meet the condition. The if statement didn't meet the condition. The code didn't meet the condition. That's why it didn't run. Great. So this is about inequality. This is about inequality. Anybody has any question up to this point about inequality? Then now we are on the third one, which is the greater than. We are on third, which is greater than. This is greater than. So we are on greater than now, and we say that deem A, B as integer, the normal thing. So we say greater than. If A is greater than B, then you should write hooray. You write hooray. So let's see. And it didn't run. It didn't run. So if A is, so now we know A is not greater than B. So probably if we change A to 7, you are likely to see something happening. That is it. Because A, so the condition has been met. That is why the console was able to display. The condition has been met. That's why the console was able to display. Excuse me. Okay. So it's the same for less than. So yeah, yeah, Richard, do you think I have to go to less than? Hello, Rich. I don't know if you can hear us. Yeah, Hezekiah, can you hear me? Okay, Rich, yeah. Yeah, Rich, we are not hearing you when you talk. Oh, we are still not hearing. Yeah, Hezekiah, can you hear us? Can you hear me? Okay, Hezekiah too cannot hear me. I don't know, maybe there was a delay in the feed. Yeah. Yeah, Ransford, do we have to continue with the greater than and with the less than? Do you think? Okay. Yeah, Yali, how about you? Yeah, and then what about the greater than or equal to? I think the greater than or equal to and then the less than or equal to are also very clear. They should be clear at this point. So this one will go for the same thing will go for the less than, yeah. So if we are doing greater than or equal to, let me not use anything different again. Let me use this one and then just say greater than or equal to is greater than or equal to. So let's change this one to 5. So we say that if A is greater than or equal to, so when we run this, we are likely to see the hooray display. we saw now yes, now the hooray. I don't know why this thing appears like huge every time it was something small like this. So the hooray has displayed. Wait. Then let's change this one to like 3. If A is greater than or equal to B, then let's run, and we are likely not to see anything because A is not equal to B, 3 is not equal to 5, or 3 is not the same as 5, and 3 is not greater than 5. So I think with this up to this point, everybody is quite okay with it. Yeah, new one, and name it logic. I need to add a new module and then name it logical rather. That one should be purely logical operators. So let's go. Then let me create my sub main, and then hit enter, and then let me come to project and change here to the new one that I created, logical operators. Let's save it. Wait. So I can save everything now. Good. So we are coming to talk about logical operators. Now, so logical operators, we will say that logical operators, they basically help us to make decisions as to whether something, if two conditions meet, two Boolean conditions. This is where Boolean actually works well. So they are actually Boolean conditions. They are Boolean logics. What are these Boolean logics? Bool is simply true. When we are doing the data types, I told you that Booleans are simply true or false. Boolean is just true or false. So if something is a bool, it is by default a bool is true. That Boolean is true. Boolean, like this. When you go to some languages, you are going to see bool. Bool this way. So Boolean or bool is simply a true or false data type. Then when we come to logical operators, that is what we use more. But before we even get to know what they are, okay, let's get to know what they are before we move on. There are basically, as we are working, there are basically 4. There are basically basically. That's to tell you that there are others. There are plenty. If you do physics, and you do logical gates in physics, that one be plenty like that. But for here, for programming and for the purposes of our learning, we will basically stick to 4. So the 4 Boolean logics, or the 4 logical operators that are like common. The first one is AND. The AND operator. AND operator. Let's move on. If you go to some other languages, you are going to get this Boolean AND looking like this. Boolean AND. The AND logic in other languages, it looks like this. Let me put this in a bracket so that you see the separation. So I just bring it. I don't want to confuse you with which language, but in others, when you see this in another language, you just know that we are talking about this AND that we'll be using here. Good. Then the next logical operator is what we call or, which in other language they use 2 pipes to represent. They use 2 pipes to represent the or. But here we will use or, like or, common or, ordinary or, that you know. Ordinary or. Good. The next one is not. The next one is not, like this. Not. Then the not, when we go to other languages, not is written this way. And some also use it in this format. Some other languages use it in this format. But this format is not very common. It's not very common to see this, but it's very common to see that. So we have and, we have or, then we have not. Not. But this one, like I said, not very common. Let me even do it. So you are likely to see this one and that one. Good. Then we have the last one, which is XOR. XOR. So we have XOR. This one, I haven't seen it a lot in other languages. I can't speak for XOR. XOR is on its own. XOR is on its own. You are not even likely to use it. You are not likely to use it, but I'm going to give you an assignment on it. Even though you are not likely to use it, yeah, I'll definitely give you an assignment on it. We are now going to learn about the logical gates. As for here, excuse me, you shouldn't be going to the classroom, the normal classroom. But as for this one, I'll take all of us to the normal classroom for us to learn some theory. Because this theory, if you get it and get it very well, it's a very interesting theory, the logical gate, what we call the truth table. We are going to look at what we call the truth table. The truth table. You can create a truth table for and, a truth table for or, a truth table for not, and a truth table for XOR. I'm going to do what our teachers have been doing to us in the classroom. I'll help you create a truth table for and or probably for or. Then for and, then I'll let you create for not and XOR as an assignment. Most teachers will do. Let's learn the logical gates. Then the time is fast spent, so let's learn the logical gates. Let's go. So I created this document so it can help us learn the logical. Please, we are going to talk about the truth table. The truth table, and we are going to do the and. So the and logic. The and logic. So this one is and logic like this. This one is the and logic. Let's remove space after. Good. So for the and logic, this is how it looks like. Let's insert a table. Then the table should have, I think, 1, 2, 3. Now, we are saying that A, B. Good. Then we are saying A and B. A and B. Please, this one is let me put something there. So A and B. We are designing a table. The table must have 4. Yeah. So this table is what we call the truth table. The truth table. Oh, where from this? This table, we call it the truth table. Let me make everything here good. Now let's start. The truth table shows us how if two conditions meet and both of them are true or false. Like I said, it's a Boolean gate. The logic gates are simply Boolean gates. So if it is true or false, how will it be? So if A and B, so like this, like our normal A and B. Hey, what kind of virus is that? Trojan horse. Yeah, Trojan, they say common. A and B. So we have if A is true and B is true. If A is true, so if one side of the logic is true and the other side is true, then definitely the statement or the result is going to be true. If A is true, if and, like the two of them must be the same thing. True. If one side is true and one side is true, then definitely the result should be true. So if A is true and B is true, then A and B should be true. A and B, not A or B. So we are saying A and B, the two combined. We are looking at the two. This is not like comparison, keke. We are like the two is true. When we have true, A to be true and B to be false, and so we are looking at A and B. They should both meet the condition to be able to produce a true answer. They should both meet the condition to be able to produce a true answer. That is it. A meets the condition, B doesn't meet the condition. So definitely the whole statement will be false. The whole statement is going to be false. Let's do that. So A doesn't meet the condition. B meets the condition. So what is it going to be? So let's just say that the condition is, let's take a condition here. Amma is a girl. Amma is a girl. Let's just put that condition. Amma is a girl. A says false. Amma is not a girl. And B says, oh, it's true. Amma is a girl. One side didn't meet the condition. They must all say yes, this is true, before the entire results will be true. So when we say all sides must meet the condition, it means that whatever statement, whatever condition you put there, whatever thing we put there, both A and B should be true before we can say it is true. So if one side is false, even if one side is false, the whole statement becomes false. So the last gate, so the last gate is false, false. So if we have false and false, what is it going to be? Thank you. That means you've gotten the concept. So this is the logical gate for AND. This is the logical gate for AND. The AND logic. Now let's go to the truth table and then do the OR logic. The OR logic. The OR logic. Now the OR simply means one side must meet the condition. Let's clear everything. At least one side must meet the condition. At least one side must meet the condition. So let's do this. Let's do true. Let's do true, true, false, false. Then let's do true, false, true, false, true, false. Okay. So now let's start. We say that the OR means one side must meet the condition. At least one side must meet condition. At least one side must meet condition. So you cannot forget that. So true, true. What are you going to get finally? Somebody? What are you going to get finally? One side must meet the condition. So if you have true, true, what are you going to get? Thank you. If we have true, false, what is it going to be? Thank you. If we have false and true, what is it going to be? Thank you. And if we have false and false, what is it going to be? Thank you. We are grasping the logic. So, oh, sorry, I used and. It should be all. Yeah. So we have. So we have. This is the logical AND gate, and then the logical OR gate. Logical AND, and then the logical OR. Beautifully done. When we talk about the nor is neither or. That one I'll give it to you as assignment. Since you now know what the and does, and then the or does, how the and gates look like, and then the or gate looks like. Create another truth table. This is what the truth table looks like. This A and B. This is the truth table. Then the results. Then use the nor, neither or, nor, neither or. So if we say that this one must meet the condition, listen, I'm giving you the nor logic. Like I'm explaining it to you raw. It's very straightforward. If this one says one or, this is all. So the or says that one side must meet the condition. The nor will say that neither side must meet the condition to make the statement true. If even one side meets the condition, the statement should be false. So none of the sides must meet the condition to make the statement true. That means that it is the opposite of this table. It is the opposite of this table. So if you are checking it critically, by now somebody has done it in his head. Because if the opposite of this table, then let me turn the table. Let me turn the results. If I turn the results, I'm going to get everything. So that one they have even told you what it looks like just now. Good. I'll send this thing onto the platform, onto the Discord. So don't worry. So that you all look at how the truth table. Everybody that you see it later will know how the truth table looks like. Good. So that is that about the truth table, and that now brings us to using this truth. So go and do not. Even that one cry is also simple. That one cry is also simple. The true must be not. Both you negate each side. Once you negate this one there, you apply some mathematics, then you get it. So as part of the assignment, I'll probably make you draw all the tables. I'm giving you a call already. Good. Now let's go to using it. We are already now using the if statement, so there's no worry to actually using the if statement at this point. So if let me try a boolean gate. Okay, so let's say dim A B as boolean. So we say A equals true, something like that. B equals false, something like that. If A and B, then if A and B, this one we are not saying if A equals to B or if A equals to, because it's just the boolean that we did, what we just did, the truth table, and we brought it here. So let's just make both of them true like that. Let's just make both of them true. Then we say if A and B, then it should print out probably A. Or should print out, how do we call it, true or false. So let's see. Console dot write line, and then console dot write, then console dot read, console dot write, console dot read. Great. So we will just say true like that. If A and B, we just say true. So let's run this. So it has given us true. If A and B, this is not comparison operators. This is actually boolean. This boolean. If okay, let's use real practical stuff and then see. Let's do something like dim then probably E as decimal so D equals 4.5. Oh, sorry, minus D equals 4.5, and then E equals 7.3, something like that. Okay, so we can do something like if D, okay, if let's make it simpler. Now we'll get it. So if D plus if D plus E equals 10, this is not comparison. Don't get confused. Don't get confused. This is not comparison. This is assignment. We are not doing comparison here. We are doing assignment. Because of this, because we brought the addition, we are actually assigning. We are not here. So if D plus E equals 10 and E is less than 10, like this, then you should write hooray, something of the sort. If you check critically, we are not going to see anything. Or should I introduce the else statement? Let me introduce the else statement. I think it will help us. So this is how you introduce the else statement. There's nothing strange about it. So let's just write this is true. Then we write here this is false. Good. So in all cases, we are going to see something. So this is how you introduce else to make it switch. If, then you write a condition. Else, then you bring the condition under. But we will be learning more of this as we go, so don't worry about the statement. But what I want you to focus on is what is in between here. Look, we are doing, this is an assignment, this is not a comparison. We actually have two numbers here. One is 4, one is 7. And we are saying that if 4 plus 7 is equal to 10, and 7 is less than 10, then you see, one side, if you check critically, one side is meeting the condition, whilst one side is not meeting the condition. Here, this side is not meeting the condition. So here is false. Here is false. Whilst this side is actually meeting, sorry, oh no, I think both sides are not meeting. I actually wanted to do this. Yeah, sorry. Less than, not greater than, sorry. So this side is meeting not meeting the condition, but this side is meeting the condition. So this is like saying false, true. When we come to our logic gates with the AND, this is like saying false and true, which should definitely give us a false answer, a false reply. So this is our false reply. Our false reply is the else statement. So let's check and see if it is true what I am saying, or if I have lied big time. This is false. Programming doesn't lie. What you give it is like whistlewick. What you feed it is what it actually produces for you. So this is false. This is false. So let's change here to 3. And now let's run and see. Now we get 3. Wait, why is it not giving me there? I said D for I said 3. Sorry. The top here was what I wanted to change to 3. Yeah, sorry. So let's run it again, then see. I think I will have to take the logical gates again. Yeah. So this is true. This is true because 3, this is D is 3 and E is 7. So 3 plus 7 equals 10. 3 plus 7 equals 10. And then 7 is less than 10. 3 plus 7 equals 10 and 7 is less than 10. So it is true. This side is true. 3 plus 3 is equal to, 3 plus 7 is equal to 10. And this is also true. 7 is less than 10. So definitely we are going to get this answer. But if we should change this to like say 3, 3 plus 3 is not equal to 10. It's not equal to 10. So this makes this side of the statement false. Whilst it makes this side true. Excuse me. Whilst it makes this side true. I think I should relax the mind of everybody now. We have 6 minutes. More on this next week, I think will be appropriate. But since I've touched on it, what I'll do is I will give an assignment just on the and then the logic case. The and then logic case. But please, everybody should set up. I'll be sending you a Google Classroom link to join. Just when we close with the lesson, I will send a Google Classroom link. Everybody should join. That is where you'll be submitting your assignments. Because that's why I'll be posting your assignments. So when you do the assignment, then you upload it there. When you upload it there, then I mark for you guys. Okay. So this is, I think that will be all for today. I think we have drank enough water for today. Yes. Anybody with any question?